Okay, it worked. Okay, good morning, November 2nd, week 3. And today we'll be going over Excel chart types and basic chart types, and then we'll look at them in Excel and go over a little bit about how you modify the styles and the individual pieces of a chart in Excel, and then we will move on. And this coming Thursday, I want to do another Python notebook on looping, and that gives you at least an introduction to the 3 basic types of statements in computer science. But then everything's, practice, 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 just like anything else. And they reiterate that in our book, which I'm gonna be getting back to. I think it's 20, chapter 20, page down, down, down. Yes, part 3, creating charts and other stuff, visualizations. There we go. Okay, so I'm just going to run through chapter 20. They get going with what is a chart and creating them and an overview of them. But I wanted to do the next section first. I didn't want to create a chart. I want to talk about what the different charts are, and you use them in everything. You use them in Domo, Python, Excel, Power BI, Tableau. So I want to get down here to charts. Choosing a chart type. Okay, so I wanted to go over these basic 6 different chart types and some of their subtypes. And again, we are in intro to charts. So I'll be kind of bouncing back and forth a little bit between those 2, just to make sure I stay on track. Okay. So here we have a sample of different types of charts in the book. And if I go to intro to charts, I want to say that's, here's just a basic chart, sheet 1. Sheet 2 is a basic line chart. Where is that? All 4 of them. Come on. There we go. Sheet 9 has these different types of charts. You've got a column chart for website visitors, and that has been converted to a bar chart on the right. And we'll go over all those. And we got a line chart, then we got a area chart and a pie chart, and then this spider web radar chart. So yeah, there's depending on the data, there are different ways to visualize the data. So we'll start going over some of those basic types. Let's see here. Column charts. So let me make the book real small so that it just stays visible. Column charts are real good at showing relative amounts. Not necessarily like this is time span. It doesn't necessarily have to be time. Sometimes time is better with a line chart. But anyway, this is the kind of data that you see being used in a column chart. Then we've got this widget and sprocket sales over here in another chart. Widget and sprocket sales. I know we've got it here somewhere. I thought we did. Here we go. Widget and sprocket sales in different types of format. These are all column charts. The one in the upper left-hand corner shows the pairing of the data by month. And then there's There are subtypes, which you see in the upper right corner. That's a stacked column chart where you stick sprockets and widgets on top of each other so that you can see the relative totals. Like when you do a column chart side by side, you can see the proportion of sprockets to widgets pretty clearly, more clearly maybe so than you can in a stacked column. But what a stacked column does is give you the total of both so that you can see um, any changes in like total widget and sprocket sales if they're the only two things that you sell, like on the Jetsons. Spacely sprockets and Cogswell cogs. It's cogs, not widgets. Cogs and sprockets. And then you've got another column chart here that is a stacked column chart that is a percentage, not an amount. And each column equals 100% of the widget and sprocket sales, but it shows you in relative proportion. And then Excel does some cool 3D stuff that we'll talk about more when we go into chart subtypes and editing and whatnot. So that's a column chart because it stands vertically, like the column in the Roman architecture. But you stick it on its side. Some data looks better on its side, especially, I believe, as the book points out, when there's a long label, when you really need that text, like here in this bar chart, when you really need this text over here to explain the bar, there can be a little more real estate if you do it this way. But again, it's just really what you think tells the story the best. And sometimes you'll have standards, like depending on how high you're presenting data to your leadership, you may find that a particular executive likes things in a certain way, using a certain color scheme, and when they get a lot of information presented to them, it needs to be consistent. So be on the lookout for that standards when it comes to presenting data. So that's a bar chart, column chart on its side, and it just goes over here to, again, here's the percentage of the results, as your data is in a percentage as opposed to in raw numbers. So that makes sense. But you don't always, you see here, and we'll go into this in the, when we talk about editing them, you have a scale along the bottom here on the first one. But when they changed it to a 3D chart, we don't even have a scale. We just have relative proportions. There's every option under the sun, it seems like, when how you want to format these things. And then a good old line chart is really good for date data. Not only date data, but it's particularly good for date data. But there's some options this can be a little overwhelming as far as the number of data points. Let's see how big the sheet is, and it's only down to the bottom, 677 rows of data. And it makes quite depending on the variability between points, this thing can look quite a bit like I don't know, EKG or whatever. And then, of course, the size of the chart helps smooth that out. But still, there's some other formatting things that you can do to add smoothing to these jiggity jaggedy lines. But that's a line chart, really good for showing trends across time. And then we've got another line chart. That's showing more than one series of data. all using the same category, but you've got different amounts. And notice some of the data is blank here. So these different series of data can come and go within a line chart. And again, you're using time, but it's based by the year. Pop back over to the book, make sure I'm not missing any. Again, this is just methodically going through 100% stacked column. Yeah, that's where each of the columns are stacked by percentage, not by amount. And then line charts. And again, the book, after you start line charts, they stick on the, I guess it's got to go on the next page, but that's annoying when they cram a figure in after you've already changed topics. Yeah, so there's that line chart. And yeah, that's a good note. There you go. All the values have to be positive in our next thing, which is a pie chart. Line 3. Oh yeah, this is just to show you that a 3D line chart isn't very useful. I think that's the only point they go to make in the book. So yeah, not every type of chart works well with every type of data. And then you have the good old pie chart, the much maligned pie chart. Particularly good at showing proportions of data in relative to a whole. If that's the story to tell, it's kind of hard to beat a pie chart, but there's other ways to show it. Sometimes just a sorted data table, because a pie really, you've seen them, a pie chart with 40 wedges starts to just blur the whole point. So anything from most of my reading from folks that actually study visualization, if you've got more than about 7 wedges, a pie chart starts to become less and less effective at truly representing the data quickly, which is what graphs are good for, to the user. So here we have that pie chart, and I think, bring the book up again. Pie chart. Yeah, the next tab shows a pretty cool kind of automagic chart that's called a bar of pi. If you have related data that you would like to explode into, instead of doing 4 pie slices in this large light blue area on the right side of this pie, you can do a bar of pi, which is a way to show some granularity without just using a traditional pie chart. And you also have pi of pi charts, which I think they mentioned. I thought they mentioned it. No, let me show you that just in case. It's useful. If you go into, and this is back to Excel, I was trying to keep it generic, but do some Excelism here. If you go back to insert charts and pull down these, you can see there's more pie charts. There are a pi of pi, and using the exact same data, you can just change the pi type. And I'm kind of getting ahead of myself, but I did want to show a pi of pi, and then say okay. And that if another sub pie chart to your pie chart is better, you can use that. Yeah, and I don't know why OneDrive keeps telling me can't save. If I click on the floppy, it seems to wake back up. Is my audio clear, guys? Can I do a comm check? Have I had any sketchiness?
Sounds good here.
Yeah.
Solid. Okay. Yeah, I'm not sure why. This file that I am operating on is on OneDrive, so you have that auto save, um, which really saves. I love it and I hate it. A little tangent here. If you haven't used OneDrive or when you're working in Google Drive, if you're working with actual Google Sheets or Google Slides, it auto saves, which sometimes you don't want to do that, right? When you bring up something on your desktop, it's just on your PC, and you do a bunch of stuff, you want to say never mind and just close the file and don't save, right? Well, when when you're working with OneDrive, it takes a little more mechanics to turn off the auto save. So the stuff that you do kind of automatically saves. And I don't know, I got a love-hate relationship with it, in case you were wondering. So I'm gonna go back to that. Insert charts, more pie charts. And I'm gonna turn it back into a bar of pie so that the next time I come in, it looks like the book. Boom. And well, we can talk about that a little bit more maybe in the next hour or the third hour. It's automagic, the way it knows region 1 salary, region 2 salary, region 3 salary, and region 4 salary are over here in this bar. And it can be a little difficult to work with. But let's continue with chart types. And then, yeah, scatter chart. Do, 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 do. Where is my scatter chart? I think maybe we go into that in another chapter. That is a scatter chart. I want to say I got one in my Arkansas crime data, or anyway, scatter charts in general are good for continuous data, like continuous numeric data, where you have the good old X variable is your independent variable, or the thing that causes an effect on something else, just like we talked about with correlation in the basic stats course. So there it is. I'm trying to remember what I did when I was going through this. I think I had a scatter plot in another file. I did this over the weekend, but we will certainly come back to it. And then we get an area chart, which is one of our tabs. Intro to Excel charts. An area chart, yeah, shows the total, and then each elements, each columns, each attribute's contribution to the total. So it's kind of like we saw in that other one. It's kind of like a bar chart. You can use it either way. So we've got the stacked bar chart, or I'm sorry, a stacked area chart, and then we've got a 3D area chart here, which you can kind of see. Product C is stuck behind in a 3D area chart. So depending on your data, that's not even something that you would consider. But there may be data sets where something like that would work, and it's easy enough to change between the two. Okay, now here's one that I had no previous experience with. Radar chart, otherwise known as, you can pull it up on Wikipedia. It's got a bunch of other names. A lot of them have to do with spiders, because you can see the genesis of that. But what it does is show you the data changing from from point to point, and these can be months, these can be um, other factors. I read a good article on these over the weekend that showed factors of a car like weight, gas mileage, price, maybe seating capacity, those sort of things. And then it showed a radar chart of those different factors for about 20 different cars. And that was used as a side by side comparison. And it starts to be where, depending on these factors, the shape of the radar chart starts to kind of show you which factor is more significant or larger, just like we have snow ski sales, of course, in December when everybody's getting ready for ski season. You'll notice the scale isn't really out here. It's just showing kind of relative contribution um, in this kind of graphic form. And is it Jim or Dave? I apologize. Which one of you are the quality guy?
That's me, Dave.
Dave. Yeah, they were saying this one is used a lot in quality programs to show, I guess, contributions of different measures of quality of a thing or of a process. Or any experience with these?
It's just what am used to. I've never seen this chart before.
Yeah, I had not either. I mean, I'd seen it, but like on it seemed like I saw it when you drop down this chart menu, and I'm like, spider chart, why radar chart. And so I wanted to look it up because it's in this book. And yeah, so like this shows you uh um different factors going around. They're all, January through December. But it shows you the overall change in value in relative terms between January, December, and then of course February, and then it just drops off to nothing. Snow ski sales kind of start in September and ramp up in November and max out in December. Um, and then you've got water ski sales, which of course are more, proportionately um, in the summer. But that's a radar chart using two data series, using two attributes: water ski sales and snow ski sales. Just a radar chart with just one column, but different rows, 6, 8, 10 different rows, starts to draw a shape that you can then kind of compare visually with another shape. And I guess if you're used to looking at radar charts, you start to see those sort of things. But as always, you can represent these two attributes, these two columns, in different types of charts. So this is the bar chart version of the very same data. I think it gets down to what folks are used to, and a lot of these are pretty niche. They there are some of these charts I never heard of, and they only mean something necessarily, to somebody in a financial role or whatever, but it means everything to them. So, but these are the basic charts. These are most widely applicable. So yeah, that was a new one on me, radar chart. And then of course we got this surface chart, which I read about and I read about and I read about, and it still doesn't really make sense to me. It's a visual depiction in 3D space of this 2D data. But I couldn't quite come to grips with what I would use that for in practical terms. I think this is leaning way towards the data science side. Any of you guys see these sort of things in your neck of the woods? Surface chart? Me neither. Okay. And then you've got a bubble chart, which is a lot like an XY or scatter plot. Um, I looked and looked and looked at this example, and I don't love it. But this is sort of like a scatter plot, where for this one, you have uh, a participant in a weight loss program, and you've got their original weight across the x-axis. So that would be somewhat your independent variable. And then you have on your y-axis, you have the number of weeks that they have been in the program, which to me is not the best use of an x and a y, because their starting weight on the x does not determine how many weeks they've been in. And what they use the bubble for is their actual weight loss. So a bigger bubble means a bigger weight loss. And you can kind of see uh, heavier folks with more time in the program have a higher weight loss, kinda. But while we're talking about theory and everything, I would have put um, the number of weeks in the program um, on as the bubble, or as the x-axis, and the weight loss as the y, because you would think as weeks go, as they increase time in the program, their weight loss increases, which is kind of true. I mean, you got this big bubble here um, at the 5 week point, and then they've um, then they've lost some more weight here. I don't know. Like I said, I'm not in love with the design of this chart, but that's a bubble chart where you can display a third aspect of the data if the x and the y and the scatter plot doesn't quite tell the tale. It's sort of a subtype of a scatter plot where you can use a bubble to represent a third variable. Okay. And then depending on the type of data, this stock chart will give you the open, close, um, and and high. These are different subtypes of the same of the chart, um, using the same data. So you've got the opening price on July 24th versus the closing price, um, and or the I'm sorry, the low and the high, and and where it closed. So you can see the kind of the shorter line shows that the the distance between the low price of the day and the high price of the day was kind of small, and then over here you've got quite a bit more, but I don't think. Yeah, there's volume. They throw that in there. That's important because that affects the variation. So that's a stock chart, but I don't know that any of you guys are necessarily working in the stock market, but it can be used for other types of data that are similarly arranged. And here they changed it to temperature. So the average is just the midpoint of these lines. So I don't know that these orange dots really mean much, but this does give you a way to show temperature variability. The shorter the little vertical line here, the less the range was between high and low. So that could be useful depending on what sort of data you're working with. A histogram is great for showing the distribution of the data. In fact, they've titled this one test score distribution. And inside of your histogram, you've got bins. I think we talked about this a little bit last time. And you can modify the number of bins or the size of the bins to get a more granular look at your data. But this just shows a histogram is different than a bar chart, because remember a bar chart, this, like, for example, this 74 to 83 thing here would have been a like a category, and this would have been the amount of things in that category. Whereas in a histogram, it's the number of scores in that. So it's similar, but I guess mathematically used for a different thing. So this tells you your overall distribution of your data. So you've got 32 people whose scores are between 74 and 73 inclusive. That kind of just gives you overall view of the, like, if it's normalized, or if your test, if it's skewed left or right, just like we went over with last week. And guys, I do apologize for repeating myself. Hopefully it's not a terrible waste of your time. And then a Pareto chart is a sorted column chart, where you've got the number of occurrences on the bar. Like this was why is a categorization of complaints about a restaurant. And so you've got 37 folks that said it's too noisy. And then you see the relative contribution to all the complaints that we have, by this line. So we're saying like what, 7% of the or so, 7 or 8% of all complaints are because it's too noisy. And then as you go across the way, the line, as these accumulate, the Pareto line gets up to 100% by the time you get to the last category. And yeah, again, it sorts, so that you can see the relative contribution. Like for example, what is this? 20. What if we go over to the right? 50%. So the 50% line. Yeah, I was reading the wrong scale, guys. When I had my mouse pointer over here, I should have been looking at the scale on the right, because the scale on the right is for the line. The scale on the left is for the bars. So yeah, it's more like 15%. Yeah, for that first bar, too noisy. But then, like, if you wanted to know the low hanging fruit, what are half of our complaints, you run across on this 50% line, and you can see that it's these first three categories. Fixing those would solve half of your complaints, as opposed to the other 1, 2, 3, 4, 5, 6, 7, 8, 9 types of complaints. So there you go, Pareto chart. Waterfall, not a whole lot of experience with this one. Gives you relative change, though, as you move like through time. It gives you cumulative, and when you start seeing negative amounts here, it starts reflecting that in the chart. And if you guys use these particular charts extensively, or regularly at least, you would hop in, right? You would come off mute and say, I use that all the time, Don. Let me tell you about it. Right?
Exactly.
There you go. Somebody let me know I'm not alone out here. Okay, we're coming up on quarter after. The next one is a statistical chart that we have talked about. So just got a few more weird ones to go through that are part of your standard load in Excel, and then we'll do some editing of them. Okay, let's come back at 9:30 cell phone time. And now, resuming chart types. Share the screen. Okay, just a couple more to go through here, guys. Just a few more. Box and whisker. This is and apparently these are new, just in the last 4 or 5 years. Histogram, box and whisker. It it tells you which ones in the book, which ones are new to as of Excel 2016, which I thought box and whisker was older than that, but maybe not. Anyway, what this thing does is shows you uh, basically the statistical distribution, the min of the placebo group. So we got four different group number things here, four different categories, and then values for each one. For an observation is what that's called in data speak. So then you have a value or an observation in the score column for that category. For this, it's medical, like whether you got the placebo or you were in treatment group A, B, or C. So it just goes down through that data there, all that their data, and produced four separate box and whisker plots, one for each category. So what you have in that, and if I hover my mouse over, it'll show you that the minimum score, and this could be, well, it doesn't look like it's blood pressure or cholesterol, but some clinical measurement of whatever they're trying to affect with some drug trial. It's just an example, but this shows you the lower, and a box and whisker can go horizontal like that, or vertical like that, or horizontal. I've seen them both directions. But for this one, it makes a whole lot more sense for it to be the way it is, where you have the category along the bottom axis and the value that you're representing on the left hand axis. So the minimum value of everybody in the placebo group is that bottom whisker is what that's called, that bottom T, upside down T, and the maximum inside is 2458. So let's go over to look at the placebo stuff. Does that look right, looking at the data? So I'm looking for 2458 in placebo. 2402, 2458. There it is. So yeah, row number 9, that shows you max. And then the box represents the middle half of the data, the 25th percentile and the 75th percentile. The line going across the middle is your median. Let me look. Let me cheat. Let me go back to the book. I think that's your median, and the X is your mean, your average. Yeah, yeah. The on a box and whisker by by definition, the line is your median score, and the X is your mean. So that will show you if it's skewed left or skewed right, depending on how far away that X is from that median line. I'm trying to think if there's anything else. I think that's all the elements. Min, max, yeah, and this little data table over here helps highlight the values in here. I'm curious if they did this with a formula. Sorry, going off script here. Yeah. And they've used a name, I believe. Group 1 is a named entity. You can select a range of data and name it so that you can use it instead of the A2 colon B4 or whatever. If you're using, particularly in like a static data set, that you're just doing stuff over and over and over and over and over again, it may be useful to assign an alias, a name to that range of data. I'm trying not to get ahead of my workshop next week. I think I know it's going to be much more thorough as far as what the different techniques and whatnot. Okay, so that's a box and whisker. Statistical shows you the distribution of continuous data. Sunburst. This is cool. And I I looked at this and went, what? Yeah, and I was arguing with with the data because I don't know that I agree with this data. Where'd you get that data? Uh, but it shows you a really interesting way to look at categorical data that is hierarchical. Um, and last class we had a fella named Damon that used a sunburst diagram to show like I think it was counties and then like income demographics and racial demographics and stuff like that. Um, that was kind of hierarchical, like this stuff is. So what you've got here is the center donut, which is just a subtype of pie chart, but this does it all for you automatically. This center donut is the left-hand column. The center donut is the top of the hierarchy of the data, and then uh, a a top level uh, grouping can have zero or many subgroups within that hierarchy. Like we got what old time down here in row 21. And so of course, the way my brain works, which is warped, I immediately looked at that and I went, old time string band. I was born to play the fiddle in an old time string band. My baby plays the guitar. I picked the banjo now. So I'm wondering if somebody actually had that song Wagon Wheel in their head when they came up with this. Come on, somebody's got to come off mic and tell me that. Slightly entertaining. The song Wagon Wheel by Old Crow Medicine Show and Darius Rucker.
Yes.
Wagon Wheel.
Yes.
You've heard it. Yeah, I'm not alone.
Yeah.
Somebody tell me I'm not crazy.
You're not
You're
crazy.
not crazy.
You're
Okay.
not.
I thought that was funny. I wondered if the author of this didn't have that in mind. But there's an awful lot of data here. But it's a way to represent hierarchical. So subordinate to the old time genre, you have string band and banjo, and then here's the number of let's say tracks on Apple Music or whatever. So that's where you get this proportionate size in the wedge is over here in the data, in the number of tracks. That's why old time is the size it is. That's why pop is the size it is. It's just like a pie chart. It gives you things in their relative contribution to the whole. But then it pops out here. It's almost like a pie of pie for every wedge, which would be impossible to read. But I think this one does a pretty good job. You can argue with whether or not rock has no subgenres. Honestly, rock and roll has no subgenres. What about metal? What about punk? Hello, I think this data is absolutely prejudicial against rock and roll. But there you go. A useful chart if you've got that kind of data to represent. Okay, and then we got into some stuff that I'd never seen. Oh no, a tree map. This is exactly what you've got in the sunburst, in a group of boxes instead of pie charts. You've got these color schemes, which get to be, I beg your pardon, which get to be difficult to determine their relationship to me. I thought this is interesting, but depending on your your color scheme here, it can be difficult to tell what's related and what's not. Like we know from the circle diagram that this brown block is our largest genre, and it has old time and I'm sorry, old time is the genre, string band and banjo, and the size of the block shows its relative contribution to the whole. Um, so, and our next largest, if we go back to the sunburst, our next largest wedge in the pie was pop, and it reflects the same in the tree map. So it's just a different way of showing the same sort of thing, hierarchical. But like I said, it's easy to tell the stuff that has a subgenre um, by these color schemes. But then it's as the data gets more granular, you I think you maybe kind of lose some of its readability. But there you go, a tree map. Funnel chart, yeah, that one. There it is, but not something I'm used to dealing with, and I've never ever worked in sales or anything like that. But this shows you maybe potential bottlenecks in a process. Um, there you go. And a map chart. Now, I've had some fun working with these, trying to figure out a way to do county level data, like only in one U.S. state, like in Arkansas, because I was trying to help uh, Damon and another student work with like county level demographics that aren't necessarily on a chart, that a publicly made chart. And if you this map uses a lot of magic from the Microsoft Bing, and the one in Power BI does too. I don't know where Tableau. I think Tableau uses Google Maps, which, depending on uh, your experience and everything, I kind of like Google more than Microsoft when it comes to that sort of thing. But anyway, you have data here by country, and then you can do a map type object that will graphically represent that, almost like a bar chart. You could do the same thing with a bar chart, but it doesn't show you where on the planet that country is. And you can do, if you just have like United States data, it does a pretty good job of narrowing the map down to just the United States. And then there's some other options and whatnot. But that's a relatively new chart object or chart type in Excel that apparently just came out with 2016. Some of the best chart mapping charts I've seen are actually, you need a web developer. There are libraries of code that will generate a map that is interactive, and it works really well. But you can do them. You can do them in Excel and Power BI and Tableau. And what about Domo? You guys ever any need to use a map chart type in Domo?
No, I haven't seen a map. No, it's mainly bar charts and other types of charts like that. They're a little easier to read,
Yeah,
more
the basic.
definitive.
Yeah, unless you're looking at geographic data, yeah, there's not really much cause for them. But like I said, Damon works for Blue Cross Blue Shield, so they look at county level, because so much data is published at the county level for like county health departments, and census data and stuff like that is published at the county level, and that's the easiest way to get to it. And it does a relatively good job of recognizing those county names, as long as you get them right. I think counties there's a particular code for counties and county level cities. Like Virginia has some cities that are not in a county. And then you have some counties that don't really have an incorporated city within them. It's kind of weird. And then you got parishes in Louisiana, so there's always some kind of challenge getting this data lined up. Okay, so that is the types of charts. It seemed like I had a chart type thing in the modules I wanted to point out. Modules, there it is. And I'm really bad at finding text on a screen, or like when I was looking for the values in the spreadsheet, I think my eyes dart around so fast that I can't concentrate. Yeah, there's a PowerPoint in here, chart types. I usually use that, but I think it was more useful being able to talk in terms of Excel, and it worked better. So there a little bit more information in chart types there if you care to read that. But there was something. Oh, this PDF. That's what I wanted to show you. This PDF, choosing chart types V4, comes from Domo, the software near and dear to our colleagues here from CAE, and it. Well, I'll bring it up. Let me see if I've got that in my downloads. I'll just download it. It'll preview it. I am sharing my screen, right?
Yes, you
Okay.
are.
God, every once in a while I forget to hit share screen, and you guys are probably wondering what in the heck I'm talking about.
Did you hit the recording?
I believe I did. Yes. I see the little
Okay.
red dot pulsing as I speak. Wow. Gets bigger and bigger. There you go. Okay, so this PDF gives you some options when you look at the kind of data that you have, and what and a little bit more granularity, the nature of that data. This is probably very close to the logic, the flow chart that Excel uses when it guesses what to present to you in the form of recommended charts. So download this PDF and give it a look. It's too big to pull up here. But what would you like to show? We start in the middle, and then it's like a 3D flow chart of what you're trying to do, and it recommends different. Like here, I'm trying to show what do you want to show? I want to show the relationship between two variables that are numeric. So it recommends a scatter plot. And then if it's three variables, like I said, the scatter plot is great for X, and then what happens to Y as you move right along the X axis, but it doesn't really give you a way to represent the what in the dot, what the dot really means, and its score or size or whatever. So that's what a bubble does. And then a heat map of three categorical variables. Sometimes you want to show the relationship between two categorical variables, but it doesn't necessarily cover that one. No, can't cover everything, I guess. But I guess that would be comparative, not relationship. Yeah, here we go. We want to compare two variables, so we get bar chart. Anyway, it's in the classroom under modules, under foundations, I'm pretty sure. Unless I put it under, yeah, there it is, under foundations, choosing chart types. So I know a lot of, if you guys are, doing charts much, you've got your go-to charts, and it's just an exercise in creating it based on the new data. But it might be some food for thought. You never know. So there we go. Chart types. Oh, there was another chart type I wanted to go over. it's like chapter 22. I noticed, because I don't really dig into the details of Excel all that often. I did notice another chart type called a spark line, depending on the data. Where did we have just regular old data? Yeah, I cut and paste. Let me delete these. I cut and paste, did delete. I cut and pasted the data off of one of these sheets here in the file I'm working with is called Sparkline Examples. Sparklines are a teeny tiny graph that goes into one cell in the spreadsheet. And summarize or gives you a little tiny graphic. And in the book, it talks about, I think it's 22. As a type of graph. 22. 22. What is, and it goes into what is a sparkline? Well, I had never heard of a sparkline until maybe this last year, when I was trying to learn a little bit more about just data visualization theory and whatnot. And it tells me they were introduced in 2010. And I wanted to get to this. Why sparklines? Why do they call them sparklines? And I was getting down here and I was looking at it and I was like, sure enough, it was him. This book, Beautiful Evidence, came with a program, a online course by this guy Tuft. Edward Tuft is kind of a guru when it comes to data visualization. So it was, I don't know, a couple $100, and I got 4 or 5 books and a 2 or 3 hour lecture that you supplement with the reading. So yeah, this guy Edward Tuft, I was just interested to see that his type of graph was popular enough to actually make it into Excel. So if you've used them and didn't know where they came from, there you go. Pretty sure the guy's still alive. I think he's still out there lecturing. It's not like an old concept. But what they are is a way to put a graph, a chart, next to your data, so that it just kind of shows like in relative terms right next to each other how that data relates, so that you can kind of see, like, what do we got here? Average monthly precipitation in different cities. So if I insert, I think it's on the insert menu, insert sparklines, you get a group here of things to choose from. And they are simple little charts. They're not nearly as flexible as a main, Excel chart. But if you wanted to, you could insert a line graph, teeny tiny line graph for each row of the data. And what it's asking for here is the data range. So what you want is the data, the guts of the data, not any of the header data. You don't want these row names and you don't want the column data. So for the data range, we'll pick that corner, and then I hold shift and click on that corner, and it automatically plugs in the data range for me, just like it does with formulas and other stuff. And then where do I want to put this? I want to put it over here in the column right next to the data. You don't have to put it right next to the data, but it kind of makes sense that way, as a kind of as a summary. And then you say, okay, and you get a little line chart next to each city, or to summarize your January through December data for that city. Which, if this data is realistic, which I have no idea, it's in the book, you can see that there's a real bathtub here. We get kind of a rainy in Bakersfield, California. We get kind of winter rain, and then dry summer. Then it starts to pick up as you get to the next December, which sort of makes sense. And then, where's this going to be? Billings. Apparently, we get a really rainy summer. So the spark line, this could be for any kind of scientific data. It could be number of visitors to a website, anything like that. You throw a spark line in there, and it gives you a real quick a graphical representation of the data. So you can do lines, columns, and then I think is it win-loss types. We go in here to, yeah, I don't know. There's no negative data, so yeah, it doesn't really do anything for it other than, I guess we lost on a on a July. There's a gap in the data, so there's not a gap. 0 is 0. Anyway, so those are the three kinds of sparkline graphics. They're just like a bar chart, just like a line chart, only they're teeny tiny in the cell right next to the data. And yeah, there's a whole chapter on sparklines in that Tufts book. Have any of you ever used a sparkline in Excel before?
No, sir.
Never.
There you go. So maybe that's my mission, covering something new. I know a lot of this for some of it's old hat. But yeah, sparkline graphics. You can do. Let's change that. Let's put that back to a column. Now you see, if you'd like the size of a column versus a line to show the relative rainfall amounts across the months, you can represent that data however you like. And that's a sparkline. And then, who was it that was asking me about conditional formatting in the little data bar and whatnot last time? And I was completely ignorant. And I said I need to go look at chapter 17.
That was me.
Was that Hampton? Yeah. Okay.
Yes.
So conditional formatting. Let me hop back to that. It's got nothing to do with graphs, but it's got everything to do with visualization. And because I have a short attention span, I'm sure there's some initials that would categorize what I am. You can go in here and it's just a box. Yeah, there it is. So like, say I wanted to do conditional formatting for all this data. There's a chapter 17 in your book if you want to go into this in great detail. This stuff works really cool. So we'll drop down conditional formatting, and there are elements you can add. So we want to highlight any this is rainfall amounts throughout the year, right? So let's highlight anything that's less than an inch and fill it in with dark red text, and that's showing you a drought. So there's some conditional formatting. I want to say that we did conditional formatting with, it was data bars or something like that, and a pivot table was the other thing. So let me highlight all this data again and do conditional formatting, and yeah, data bars. There we go. I think that's what we had. Yeah, there you go. So that shows, again, almost like a sparkline, but not really. The rainfall amount in relative terms using a bar inside of the cell to represent the data, which this is awfully noisy. I don't know that I would necessarily use it that way. But yeah, conditional formatting does all those cool kind of things. Um, clear rules from entire sheet. Bam, yeah, puts it right back where it was. And then I want to say you can do like a heat table where conditional formatting, color scales. Yeah, like red, yellow, green. There you go. So if we choose that, and it's so nice. It previews. I'm just hovering my mouse over, and everything in Excel pretty much works this way. If you just give it just a second and hover your mouse, it'll show you preview on your chart, on your thing, whatever you're working with, before you ever actually to click it. So this shows color scales, and then you can modify those pretty much. Everything can be customized. And this book, as thick as it is, hang on just a second, just 1 second. There are places in this book, in this PDF, where it says this book doesn't even begin to exhaustively cover functionality. And it doesn't. It's a really good guided tour. But there's a whole lot more information out there, like in the individual help and on the Microsoft website for documentation. And this book is that thick. Where's my hand for comparative? You know what I mean? It's thick. And it doesn't even begin to address all the functionality in Excel. So there you have it. Powerful piece of software. But yeah, this is conditional formatting. If this stuff helps. But what they were doing in that pivot table was using this data bars, which you can do, shaded dark to light, or you can do just a solid bar like they did in that pivot table. Pretty sure they use that solid blue there. Conditional formatting, pretty cool stuff. And it's just a mouse click away. I mean, you highlight your data and start playing with it. Pretty cool. Okay. And we were chart types. And then I wanted to, just actually show you the creation process and a little bit of the editing process of the chart. So I'm going to go back because it's such a good example. I'm going to go back to Intro to Charts. Now in Microsoft Excel, now I'm off of theory and I'm back onto actual actual Excel use. Okay, so I wanted to start with, yeah. Okay, this is potentially the simplest chart that you could draw, right? Just a simple bar chart that shows these dollar amounts. A column chart, I'm sorry, column chart. A bar chart goes left to right. So yeah, this is pretty much the simplest chart that Excel could show you. So I wanted to use it to illustrate what Excel calls all these things. And again, chapter, I think 21 starts to go into a lot of the editing different. They're called elements. But to create a chart from scratch, say that we didn't have this chart at all we had was this here data. You click within your data. If it's already in the form of a table, Excel is better at guessing than if it's in a conventional range like this. So I'm going to go off script here a little bit and show my vulnerability and insert a table. So yeah, that's what I want to do. Is I'm going to turn that data into a table, which doesn't do a whole lot, but it encapsulates the data for you so that follow on, automatic processes will be a little smarter than they were. Whenever you click within the bounds of the table, now Excel kind of knows authoritatively that you only want to deal with that data. So that's insert just a regular table, not not a pivot table, just insert as a table. And the pretty much the only cool functionality that you get with that is you can sort now, sort and filter. If you drop that dialog box now, it's kind of automatic with how to sort or filter. But like I said, it makes it really easy if you want to insert a recommended chart. So to get started doing a chart, you would go insert recommended charts, and it looks at your data and guesses what might make sense, and then shows you a preview of that data. So because it is, potentially continuous data, you could use a line chart, and pretty much anytime you use a column chart, you could use a line chart. In fact, you can, doing a line chart on top of a column chart for two different data series can be illuminating. And here is the suggested column chart, which I believe is what we stuck up here, sales by month, because that's it defaults to that, because that's the quarter. So there you go. Just by using insert recommended charts, I get basically this same chart out of the box, out of the gate. But there are some things over here in this chart that came with the book. This is the one that the book came with. And then the one on the right, the larger one, is the one I just drew. Well, with Excel, these things, this is called the chart area. And you'll notice I renamed it sales by month over here. By default, it calls this thing over here, it calls this thing chart 1, chart 2, chart 3, just like it does sheet 1, sheet 2, sheet 3. But you can rename that by just giving it a name over here. Okay, so now we've got Don's chart and sales by month. So you can name a chart if it helps. So this new one, can't save. Yes, you can. Go away. This new chart that I just created doesn't have, for example, a legend. There's nothing. You don't need a legend when you only got one thing like this. But that just goes to show you there are things, elements, as they call them in Excel, on this left chart that you don't have on the right chart. So by default, the recommended charts don't necessarily contain every element that you might want on a chart. And I'm like, so you might be thinking, what? I need more elements, right? A good chart has more elements. So the way to add elements is this plus sign. Once you click on a chart, you can click on this plus sign over here. I need to get my camera off of that side. Okay, so if I want to add elements to a chart, this gives you a list of the chart elements, which are the different things that you can show on a chart. So I will, more elements are better, right? So let's have them all. Let's have data labels and axis titles and a data table at the bottom. Why not? And error bars, and let's have a legend, and let's have a trend line, and that's better, right? Because I got more elements now, right? So yeah, you can go nuts with these elements. So that's how you get them on and off of your chart, is this plus sign, which is your chart elements add dialog box. So if you go back and unclick all of this garbage, I'll go back and cover them one by one. Data labels, chart title, you probably want, don't necessarily want axis title. But you don't have to even have the axes. You could have, now you don't have any notion as to what the data represents. You just know that in relative terms, it kind of went up and then it went down and then it went back up. So that's where each of these chart elements you'll click to bring it back into your chart. You can even like turn off the chart title if for whatever reason you don't want a chart title, you can click on it. Any of these titles can be clicked in and modified. Like you just click in it like you would a normal text box, back up and say month of the year. So that modifies that axis title. You can modify, it will default if the data lets you. The chart title will default, but you could maybe this is all for one sales team. You could say software sales by month. Say, click off of that. So these individual title elements can be modified just by, you don't have to go through a bunch of mouse clicks and go modify it in a dialog box somewhere. And this one is on a weird axis, but sure enough, I have to hit the up arrow, not the right arrow to go right in that, in case you ever run into that. Back. So this is what, total sales. Whoop. Don't need to hit enter. So those are axis title elements. And again, if I click on the chart, these three magic buttons come back. What other elements can we mess with here? Oh, data labels. And these are, not every chart has every element. Depending on the type of chart, you'll see different elements. Like I want to say maybe a pie chart doesn't have grid lines. So we'll get there. Data labels. This is the preview. If I just hover over it, and then the right arrow, I believe, explodes a type. Yeah, here we go. If you've got a right arrow here next to the element, that means that there are different options to choose from. And our data labels actually would label like each column, so that you don't have to go over to the left. You don't have to go over to the axis label to see the amount if you wanted to do that. And you can stick them in the middle of the data. You can stick them inside the column, at the end of the column, inside the base, outside the end where it may be more readable. See, there's just so many options and so many different ways to get to these different things. But these are data labels. You may or may not want them. They may be too much clutter. Kind of all depends. So we'll pick the default, which is outside the end. Depending on what you're doing, you can add a data table to the bottom of the chart. I think we might have had that in one or two of the examples. But that shows you, instead of the data labels, it's got a data table. But I want to say as the data gets more, beg your pardon, more complex in there, a data table is more useful. This is just showing the data point for that month, so it's not a whole lot of use. Didn't have a chance to see what an error bar is. I'm sure that is some measure of statistical significance. Yeah, sure enough. Standard deviation, which is the same. You only have one data point, so yeah, it's pointless. So yeah, not every, go back to that. Not every element is necessary at all, but they're all there. You're like an artist. You have a palette of paint to paint your data story. Grid lines are useful. Grid lines are an extension from the axis on the left and goes across so that you can see on something like a line chart or a bar chart, you can go across. It makes it easier to tell if it's above or below what a particular line. And of course, since you have this arrow next to it, wish they'd standardize. Usually it's dot 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 instead of a big black arrow. Anyway, you can put them horizontal, which is the kind of by default. We don't really have a vertical axis on this one. This would be more useful for like a scatter plot, where you have X and Y. Primary minor horizontal, that's where it breaks it up into even more. Yeah. So anyway, those are grid lines that actually put a line on your chart so that you can see where the amount is. So let's go primary horizontal. The legend is not necessarily needed for simple data. This next one here, get rid of that. So go back to legend. Now, if you only have one data series like we have here, you don't even need a legend. But that is what sales by it tells you what's this blue bar mean? Well, it means sales by month, which, like I said, it matters more on a more complex chart. And then you may get some use out of a trend line, which is the same. It's the like the moving average of the sales. So in general, it's kind of doing like a correlation of these total amounts. But I think there's some options here. There we go. Ooh, linear forecast. What's that? So that shows you if we had a couple more months, it would start to show you what the projection might be based on a really simple linear equation. There you go. Different options for that trend line, if it's useful. So yeah, some more elements. For example, like your pie chart over here, we didn't use for example, we didn't use a legend. So if I click in the chart area and I go over to my chart elements. Oh, we are way past time. Hey guys, if I ever go past and we're on the normal, half an hour to the quarter after, if I ever go over time, it's important to get up and walk around and take your headset off, check your work email or your phone or whatever, so that you're not worried about it during our breaks. So I've gone over time, but I'll pick this up when we get back. Let's go on break till 10:30. But do not be afraid to stop me. All righty, welcome back to the third hour of the Data Patch with Don. Data Patch with Dr. Don. Let's see, where were we? We were back on, oh yeah, chart elements. All of these things you can click on. So let me make this pie chart real big here. And that, like it always says in the book, and it says anywhere else, goofing around with these things is the best way to learn something. There's a couple of things I want to cover in no particular order because I hate looking at the book and being formulaic. First of all, this is called an embedded chart. You know how when you're on a worksheet, and you've got your data, and you say insert recommended chart, or you pick your custom chart, it puts it by default on the current worksheet. But which makes it kind of easier to work with, because when you're goofing around with a chart, it makes it easier if you have the data that you're working with on, so that you're right there at the right next to each other. Um, and I will make the point that working with charts and you only have the data that you want to chart. So go through, clean out, weirdo special characters. If you're gonna delete null values, delete them, substitute them with something else. Name your columns something useful. Get it all set up um, for that chart, and only have the columns that are the data series that you actually want to represent. Wanted to make that point. Some people call that data wrangling, data cleansing, data preparation. But to me, whenever I get going and I start trying to chart, and I've got a big chart with lots of columns, or I'm sorry, a big worksheet with a lot of columns, the charting always seems to get more complicated than it needs to. So that's why I do it that way. But by default, when you create a chart, it floats on top of the worksheet where you created it. But I want to say a couple of things I wanted to point out. Everything in Excel, or most things in Excel, are context sensitive. When you have clicked on something and it has the focus of the application, I believe is the correct Windows terminology, the menus all change. Like right now, we're in a chart. I'm in the home tab, right? I'm in the chart, and there's nothing under alignment, because how do you align a chart? None of this stuff's all grayed out. So Excel knows what you're working with, and presents or takes away menu options based on that. Sometimes it's on a standard ribbon, so it just grays it out like you see here on the home tab. But it also adds uh, tabs on the menu, like a chart. I believe all charts, all the ones that I've been messing with lately, add a design tab and a format tab. Some of the things, and that's the other, wonderful or frustrating thing about Excel, depending on how you look at it, is there's always multiple ways to. Am I sharing my screen? I'm not, am I? I'm not
No,
sharing my
you're
screen.
not.
I'm not. I'm yapping away. Here's a pie chart, and you can't see the pie chart. And nobody stopped me. Nobody said, "Hey, old man, woohoo, Don, you're not
I
sharing your
thought I was
screen."
having computer problems.
No, it's always me. It's never you. If you're thinking, "Oh, I'm missing something here," it's always me. It's never you. So yeah, share screen. Share the whole screen. Sorry about that. Bang. Now, here we go. What have I've been talking about grayed out menus and context sensitive and all that, and you guys had no idea what I was talking about. So when we create a chart, by default, it puts it in the as it floats as an object on a drawing layer, it's called, kind of above the spreadsheet. So when you click in that chart, you can move it around, and it'll uh, sit on top of the data. You know what I mean? It'll like blank out the data. But I like to work with charts, like I was saying, using only a data table that has the columns and the rows, and everything's neat, everything's pretty, like in this Excel users. So we have these chart elements, as I was going into. Notice now that I'm in a table, I get a table design tab up here at the top under the green bar. But when I click in a chart area, I get a chart design and it doesn't say chart format, but that's what it means. I get a format tab. So in here is where you get all the cool styles that you can, the chart styles is what it's called. So you can, if you hold your mouse, just hover your mouse over, by default. Now you could go in and you could draw all these custom, but why not pick from a cool chart style that has what you're looking for. And if you'll notice, we're all in blue scale, right? Oh, well, over here we can change the color of the like the color palette. Woohoo! Like, yay! Some of these are more accessible than others. That's one thing to be cognizant of as an analyst, is the nature of color blindness, and there are palettes that are easier to distinguish from than others. So just be aware of that if it's a factor in your organization. So these are, yeah, these are the mono. This is how we got the blue that we got, is a monochromatic color palette where everything is the same color but it's different shades. And then you can you can go with all of these like you went nuts with your Crayola crayon box back in the day, and just pick whatever you want. There's all these different ones to choose from. So many things you can do. So that's the color palette of the chart styles. So yeah, here's another way to get at something I was talking about. You know, when you click in the chart area, you get this chart elements plus sign. There's three little symbols that will pop up to the right of the chart anytime you click on any kind of chart, and that are the chart elements, the different styles of the chart, which is just a quick menu to get you to this thing here. It's the same stuff. It's just a shortcut. There's always so many ways to get to the same functionality in Excel. And then we got filtering, which we haven't really talked about. So once you've created a chart, every once in a while you can go back and filter the data, or you can just filter it on the chart itself. Let's play around with this. Let me get my camera image back over there. Say we don't care about Excel 2010 anymore because, I don't know, we don't care anymore. If I get rid of that, should get 2010 apply. There we go. It gets it off of the chart, but it doesn't eliminate it from the chart, so that you don't have to like redesign the chart. It just hides it, you know, like filtering hides in a column, and apply. Or let's see, I want to see something else while we're being brave and going off script. I think you can, if you just filter the data, it has the same effect, because virtually all charts are linked and dynamic, and anything that you do with the data is going to affect the chart. And normally it refreshes in more or less in real time. But let's say that we don't care about Excel 2010 anymore. So we go into the data table itself and take 2010 out and say, okay, bam, same effect. So you can go at it, you know, any number of ways, as with all things Excel. We'll put that back. Some more chart element things, like here's the title, right? And again, that is just, it's a chart title. It's just a text box. So you have full control over that. We don't have a legend here. There was another way I wanted to show you. If I get out of that, go back to chart design, that same plus sign is available up here under add chart element. If by chance you forget, or whatever the case may be, that plus sign is also replicated right here. Quick layout. This is cool. Let's see if we get like a, yeah, it starts to show like a legend, chart title, legend at the top, percentage. So these are canned styles basically, but not quite. Styles a little bit more about color palette and whatnot. But these these quick layouts let you no data labels, no nothing, just the legend at the bottom. Um, this one converts it into percentages. So this quick layout is another cool way to edit a chart real quickly. Not every chart, again, not every chart has every element. It depends on if it makes sense for that style. Like, I do not believe we're going to see grid lines here, I think is the example. Yeah, they're much reduced list of chart elements for our humble, lowly pie chart. So another thing that we can do here, depending on the chart type, like on a pie chart, you can click on an individual. So we're in the chart area, right? Because we can see our sizing handles here. So the chart area is selected. And then we go into once the chart area is active, we click on an individual element and I clicked once. In this case, every data series, every wedge in the pie is now selected. So I don't want to goof around with any just yet. But if I click one more time, I get just that wedge. You know how sometimes you want to explode a chart wedge out. That's how that was done. You highlight that one wedge and drag it out of the pie, and it makes it stand out. And you can do that with any individual wedge to make it stand out. And then of course you've got these data labels that you can then move around. Once you create them, you can move them if for whatever reason you wanted one outside instead of inside because it was kind of overriding or whatever. These elements can be moved around after you create them. You don't have to leave them where Excel put them. Like by default, the chart title goes in the middle at the top. You don't have to leave it there if you don't like. If you want to, if it looks better for the chart, drag it over here. And then, like I said, you can resize the chart to make it more visible or take up more or less real estate. There was one other. Oh yeah, once you have the chart selected and you're kind of done working with it, it may make sense to put it in its own on its own tab, on its own worksheet per se. But it's not a worksheet tab, it's a chart tab. If you move the chart to its own new sheet, we could call this new sheet Excel usage pie chart. It'll default, of course, to the useless chart one, but we can call this, and this is going to be the name for the tab at the bottom, Excel usage pie chart. And it creates, now it's its own tab. See down here, this we still have all of our other stuff that I went through this morning, all these different, but now we have an Excel usage pie chart tab that is just the chart. Now it's still pinned to the data in that other worksheet, but we've now moved it to its own tab, its own sheet, a chart sheet. But all the same stuff applies as far as the chart is concerned. But I believe, yeah, when you go to the home tab and you're on a chart sheet, none of it applies. Nothing. Not cut, paste, not look at nothing. Insert, all that stuff goes away. So you're basically limited to just the chart stuff if you put a chart on its own tab. And then there was one, oh yeah, last but not least, I wanted to say, if you right click, you can save as picture. If you want to embed this thing exactly as it looks in another object, it defaults to PNG, but you can create, that's the name. save as type. You can call it a JPEG or a bitmap. Any or a GIF. I know JPEGs are compressed, so they're smaller. Anybody know the benefit of a PNG? A lot of things want to do that now. Portable network graphics. Any of you folks that lean on the nerdier side and know the difference between a PNG and a JPEG? Okay, I'll have to Google it. I don't know. I'm more comfortable with JPEG, but I haven't seen a limitation of that PNG format yet. I'm sure it's just a Microsoft versus open source thing. So anyway, yeah, you can save your chart as a, and then it'll, of course, it'll be static. It won't. So we'll cancel. Okay. And then I wanted to show like other types of charts have other types of elements. Here we are on the bar chart. And we click on it, that chart area, and we look at the elements that are available. That's where we have all of these other, just like we did. Now this might be useful. Here's a data table. I'll go ahead and click on that. And as we start to see, maybe that matters, but I think if you had more of like a clustered bar chart, it might start to make more sense. So I'm curious, and that's the thing I really did not get far enough on, was modifying a chart. After you create it, you can click on this thing after you create it and go to, is it design? Yeah, design, and then select data. Let's see if I can do this off script. I couldn't get it figured out. Like say we want to add another column, like let's say we want to add agree to this. It seems like we can add a series name. Yeah, agree. And then the series values are here to here. Somebody jump in if yeah, I need to do more homework. That's why I said if working with chart, to me it makes the most sense to have everything I'm going to chart and then create the chart. So I'm curious here, if I make this one smaller and I run it back down here, I want to do a clustered bar chart that shows more than just the strongly agree. So say we've got this thing here, and I want to do, I'll select basically the whole table. I want a clustered bar chart. So I'm going to go over here and I'm going to say insert column or bar chart. And that's a histogram, right? Yeah. Let's do a 2D bar chart. There we go. Yeah, that starts to get kind of cluttered, doesn't it? So I can see we're separating out each rating, and you guys do this a lot with your student surveys. But this shows in relative to each other in a clustered bar, in relative proportion of how many people say strongly agree versus strongly disagree for each of these questions. I like your TV ads. Disagree. They don't like your TV ads. This data is faulty. So anyway, that was inserting a chart based on the data and picking the type of chart, not using a recommended, not using the recommended chart. And then of course, now that we have this new chart, you get the same options, chart elements, so that we can, if we, now you really need that legend now, because who knows what blue and purple and green and red and dark blue mean. So that's where having a legend at the bottom, when you have 5 different categories, that matters. And then you've got grid lines here, and of course they're horizontal because that's the way that the data works, where the bar chart is, column chart laid on its side. So it makes sense to have the grid lines vertically going like that. But like here, I inserted a chart, and it doesn't say strongly agree anymore. It just says chart title. So you'd have to say customer feedback. Let's see if we click on there. Yeah, you've got to name it now. Just as easy as that. And I want to say that you can highlight a particular bar, kind of like you can a pie slice. So we've got the chart area selected, and we click on a particular data series, and you'll notice now that all of the strongly disagree bars are highlighted now. And if I want to move just one of them, I got to click on just that one bar, and it will let me, I believe it'll let me goof that up. Maybe not. I could have swore it let you do things to individual bars. Format data point. Okay, that was going to lead me to my next topic. Okay, well, let's talk about formatting now. Slide that over. So whenever you click on, let me get rid of that. Whenever you click on a chart element, if you right click on it, you'll get a format call out box, dialog box. You'll get a formatting. I'm blanking. What do they call this thing on the right now? This format chart title. Got to look at the book. Hang on. They call that something. There's a name for that particular thing that pops up over there. Arg, it's escaping me. I'll figure it out. Anyway, every element, every type of element has a, where were we? Chart types. There we go. Every type of element, whether it's the chart title, will have a format chart title workbox thing over here. God, I hate that I don't know the actual names. But if you click on a data series, which this is all the stuff in the strongly disagree column, which is a data series, you can then format just that data series. So maybe strongly disagree is something you're really worried about. So pretty much just like PowerPoint, just like you would think, you can change the fill color of a particular data series. So instead of doing automatic, we're going to do a solid fill, and we're going to pick the color, and it's really, really, really bad. So we're going to pick bright red, and that changes strongly disagree, just strongly disagree without modifying the color palette of the rest of the chart. So these chart elements can all be modified based on the type of element it is. And that's another good point. This is called the chart area, where you click kind of outside the graph itself. So the whole chart is active now. format chart area. See up here in the upper right corner. But separate to that is the guts of the chart, and that's called a plot area, and it has its own format options. Then you click over here, and this is going to be the vertical axis, so we can format that axis. And there's all these different options to format that option. You've got, you know, your fill. You've got whether or not there's a border around that axis. Let's see, solid line around the axis, and it's black. I think. Let's try that. Oh, nope, that's just going to the actual the line next to the data. I was thinking you could put a box around your. That's the text options. Size of the axis. 3D format. Yeah, guys. Sorry, I'm way off script here. I want to say solid line. Yeah, that drop shadow. Put that shadow around the text of your axis labels. So all of these elements, and here's your vertical axis. It starts to see where you can have the granularity of the data. You can work with artsy stuff like, you know, font colors and fill colors and that sort of thing. But every chart element is editable, modifiable using this this format thing over here. It bugs me that I can't remember what that's called. Okay. So those are chart types, and a little bit about selecting the data that goes into the chart and which data types are good for which types of charts. And then a little bit about editing different types of charts. And again, like, you know, like I said, we've got 2 full days of this next week to make sure to fill in the gaps and maybe be a little bit more methodical than I am. Our instructor has taught Excel in a structured format before. Can't save. Okay, so as far as basic charting, that's as much as I wanted to cover. Are there any questions or concerns or gaping holes in just an introduction to how you do charts with Excel?
Not yet.
So it's all kind of making sense. You think you could sort of start to apply these, or are all of you charting all day, every day, or at least weekly?
No, I've done charting before, but I can blunder myself through it probably.
Okay. Well, hopefully this between my soothing baritone and the book and some practice, that's the thing, is kind of making you take some time, set aside some time to do some practice. So what I want to do, I have warned you that we would be doing a hands-on Excel charting, Excel data wrangling, data storytelling, a first shot at it. So I want to talk about that. I want you to be thinking about it, and if you can get started, great, kind of, you know, maybe pulling up some data. But I want to do a kind of a data storytelling, you know, analysis, just, like an academic assignment. Doesn't have to be work related, although it could be. But I kind of want to go through the whole data analytics life cycle. So now that we've talked a little bit about, basic statistics and mean and min and max and range and all of that sort of stuff, and we've um, we've done a little bit of data wrangling with Excel, and some basic charting, some basic measurements. I want to show you something I developed last time, and I went ahead and had the entire class use my example, but this time I kind of want to, you can do the same thing we did last time, using the data set I did, which is units of things about the individual 50 US states. Or if there's some other thing that interests you, some other type, it could be, music, or it could be companies and their size versus their stock performance or their age, or whatever you want to look at. Just kind of a sample gee whiz data storytelling exercise. Okay, so I'll show you what I did, and then I would like for you guys to do something similar, but I'm not going to create the assignment and load the files or do anything like that. I just want you guys to kind of get an idea of what I'm talking about. That will be a data storytelling exercise. We're going to do one in Excel and then one in Python. Same sort of exercise. And it can be as modest and humble or as fancy as you want. Before I do that, you can delete an entire chart by clicking, and I'm going to do that because next time I come into this thing, I want it to look a little bit like the book. So I'm going to delete my customer feedback giant clustered bar chart, bar chart. And I'm going to drag these back up here where they belong. And I added a data table to this one. Actually, did I add that whole thing? Or were they both here? They were both here. But I added a data table element that I don't want on there. There we go. Okay. So let me put this away. See, put that away. And I want to say that my table I want to look at, or my thing, my file I'm looking for, was from last time. Did I do it in Excel? Yes, here we go. Another PowerPoint. Yay! So you can do this assignment that we are going to do in a couple of weeks in your tool of choice. I did charts and whatnot in Excel and paste them into PowerPoint. But this is the kind of thing I'm talking about. I did a little, just a research project. Just pretend, And here were my my research question. What relationship, if any, does this temperature have with happiness? Are people in warmer states happier than people whose average temperature is colder? Just an example. So I'm correlating basically a continuous happiness score from, I don't know what it is, 0 to 10. We'll get there. A happiness score with an average daily temperature score inside of a spreadsheet. So I've got a row for each state, and then a column for happiness and a column for, instead of telling you, why don't I show you? Can't remember which one of these. Yeah, in Excel, I cleaned up some US states data that included the 2-digit abbreviation, the full name, the name in all caps. And then I went and found a table that had their population. I found another table online somewhere that had the average temperature, again, for each of the 50 United States. And then I found a happiness score on another website that I could use to correlate these two. So that's what I got. I got 51 rows, right? Because the first row is our header. And then I've got data about each state. So now I can do a little comparison analysis on average temp versus happiness. So have we talked about experimental design and null hypotheses and alternative hypotheses? Have we mentioned that at all?
Not that I remember.
Doesn't ring a bell. Okay, cool. You'll see this if you crack open academic literature. This is the way, and we all probably got this. I think we all got this in like junior high and forgot it because this sounded familiar, but when I took research methods and all that for my degree, it was very faint, foggy memory. But you'll see this in the academic literature when they show you any sort of scientific experiment. It doesn't necessarily have to be a drug trial or anything grand like that. It can be something that you maybe never thought about. Is your null hypothesis. You always start an experiment like this or an analysis thing like technically you start with what is called a null hypothesis. And what that means is that you're going in proposition is that there's nothing to see here. There's no nothing significant will be found by this experiment, and that's just the way it's done. I don't know necessarily why you start with the, and that's why it's called the null hypothesis. Nothing, no relationship, nothing to see here, no effect. There will be no effect. Whatever the experiment is, the null hypothesis is always, well, that turned out to be not worth anything. So your alternate hypotheses are always no, there is something to see here. Either you can see there will be articles out there where they have 2, 3, 4, 5, 6, whatever alternate hypotheses based on what might happen. And this one, so my alternate hypothesis is that there is a positive relationship between temperature. As people live in a warmer climate, of course they're happier because cold makes people angry, right? Well, maybe not. So alternate hypothesis is negative correlation. And you guys, for this exercise, you do not have to do this kind of a null hypothesis, alternative hypothesis thing, because this really is experimental design. This is what you would do. For example, if you I think I hate to keep picking on you, but I've been working with CAE folks long enough that I kind of understand the line of work you're in. One of you mentioned this time where maybe adding a different delivery method or maybe gamification before and after or different ways of presenting curriculum. So you would do an experiment. You would say, and your null hypothesis is that the change in whatever it was, Dave, Jim, do you remember what? I think it was one of you two. Do you remember what I'm talking about?
It wasn't me. I don't know, unless you're talking about VR and AR stuff. I don't know.
Well, one of the things that we try to look at is the outcome. Is there a delta between old and new, or something we can correlate between AR does this method does this better than this method, or something like that?
Okay, Jim. Yeah, it might have been in what you turned in for that business question when I might have
Mhm.
read a lot into it. But yeah,
Yeah, but
it sounded kind of like experimental design, which
some of it is.
what is the change? Yeah, what's the change?
Yeah.
And then that's where you start to see uh, the statistical significance. That's where you see, we've got 600 air crews on the whatever the C123. I hate doing that because I know what a C-130 is and a C-17 is. But anyway, you've got, your population of X amount of, say, air crews that fly that plane. Or, you've got 4,000 pilots that fly the the Boeing's, 787 Max, whatever. That's your population. Then you start, doing before and after with small groups. Were the pilots more competent before and after this particular training exercise? Could be a emergency procedures in the simulator or something. It could be a change in the software where the pilot's more effective because the software displayed
Right.
something better, whatever. Whatever. An experiment is looking at before and after, and it's looking at how many folks participated in the experiment versus or how many times you implemented the experiment versus the overall possible population, and can we count on that data, or do we need to do it more to become more and more and more and more confident that our results will speak for the entire population? So, but anyway, I didn't want to get into that. You guys don't have to do anything that has anything to do with experimental design and null hypotheses and positive and alternate hypotheses. You can just tell a story. But it'll be, pick something that's, what's the relationship between stuff, or what is the nature of the data? Just descriptive. What do the top 100 companies look like? I don't know how many employees the Fortune 100 employ on average. I know Walmart's the largest employer, but I don't know, necessarily how number of employees relates to market cap or whatever metric it is they use to pick the Fortune 100. So you could do something like that, but it's, I want this to be kind of a low threat, fun thing to look into in whatever domain you guys would like to look into. And then kind of get used to setting that up and telling the story and presenting. And I want folks to kind of go through what I'm going through here. So there you go. I chose an experimental design, basically, or at least um, a hypothesis that, yeah, warm temperatures make people happy. So I went out and I found some of the data. And again, this is um, very often the hardest part. I used a multi-factor. If you this, I'll post this. Um, you can look at the actual sub categories of things that went into this happiness score. Economics, education level, population density, all kinds of stuff went in there. Um, but I don't think average temperature was one of those, which would kind of skew things if you looked at average temperature against something that had average temperature. Now I'm making myself doubt myself. But anyway, back to uh, just generally what I'm looking at. What is the relationship between happiness and temperature? And my temperature data came from this website here. So I pulled that stuff into Excel and made sure that I got rid of some of it had, like, the District of Columbia, or it had Puerto Rico on there, which are not states. So I had to clean out some rows that I didn't need. I had to make sure everything was in the right order, and that, that it started with Alabama and ended with what, Wyoming, um, and everything lined up. And then I got my columns all wrangled together, and then I did the math. Then I did the analysis in Excel, like we've seen with the tool pack and the what do you call it, the XY plot. And I found that there is no positive correlation. There is a very, very weak negative correlation. Anything Pearson R needs to be higher than, I'm sorry, R squared needs to be higher than um, 0.5 to be a positive correlation. And as you can see here, it's all over the map visually. As soon as you pull that up, you can tell that that your average daily high temperature, as it gets warmer and warmer and warmer, um, doesn't necessarily result in higher happiness. There's a lot of people out here down below that trend line that that are kind of warmer, but they're not necessarily, higher on the happiness score. Happiness goes from 0 to 80. Average daily temperatures kind of peaks out here at a little bit less than 70, but I didn't shorten the scale of my graph. So that's what I found, is that there is no clear relationship between the average daily high temperature of a United State and its how happy the folks are there. So I presented those findings here. So yeah, negative 1.4 is, or 0.14 is very weak. It is negatively correlated, but it's very weak. So it can't necessarily be seen as really, causing anything or something to take action on. So I would accept the null hypothesis. That's the language that you'll see in an experimental design article, is that if you run the data and your null hypothesis winds up being true, you accept the null hypothesis. And if one of the alternate hypotheses wind up being true, then you accept the alternative hypothesis that there is a positive correlation. And a lot of times you'll see that you got to mix in with something like the United States. You've got all 50 of the population, so there's no inferential statistics because you've got all the data for all the states. So you don't have to worry about confidence intervals and all of that kind of stuff. I think I still would like to do a workshop on those inferential statistics, but we don't have to worry about them in this case. And I would suggest that going forward, we're not going to worry about those either in your project, unless you got a really good handle on it, in which case that'd be great. But I want to wait until after we're done with the Excel workshop. So I want to hit this like in week 5. I may go ahead and let you get started on it today and next week. Yeah, we're coming up on an hour left. Yeah, a few of you've got the Python, what do you call it, to the Python exercise 1 to get to complete. So this next hour, I'll put you on your own recognizance. There's this project that's going to be coming up. There's always more fun with Python. We're going to do loops on Thursday, and I think I may go through and do a little bit more on this thing as far as the data wrangling is concerned. And I got a really cool tool that helps pull it web scrapes, actually is what they call it. It pulls data out of Wikipedia page tables so that you can use it as a CSV, and it works really well. And that helps when you're trying to find data to do an exercise like this. Okay. So yeah, there we go. For Thursday, we got Python looping and a little bit more on Excel and a little bit more on Python. Any questions? Back to the charting basics, which really was our main thing for today. You're telling me I'm that doggone thorough.
Absolutely.
Absolutely.
Wow. Wow. Well, okay, guys. Like I said, if you haven't goofed around with charts, I'd highly recommend pulling up that intro to charts file that's in your textbook chart set, and just goof around, mess it up, click on things, experiment. If there's something in particular, some type of chart that applies to your, use this time, use these hours at the end of the day to do your apprenticeship stuff, not your work stuff. I realize sometimes, that there's nothing that can be done. But I will reiterate, probably more than you'd like to hear, that your employers did agree for this to be dedicated to your learning and development, not to run right back to work. So yeah, go ahead. There's just a few that need to finish up that Python exercise. Do that. Do some goofing around with charts, and then start thinking about what you would do for a micro data storytelling project like this. And maybe if you're way ahead, start looking for the data and see what you can find out there. Other than that, I will see you in the data patch Thursday morning at 8:30.
Y'all have a good evening.